Alright, for the Unit 5 on inferences, sample statistics is a numerical value calculated using data from a sample. So this is going to be the mean and the median of the sample. You should have learned mean and median during 6th grade. Alright, so you have population mean, and population mean is just the average from the entire population. So what you would do is go ahead and add all these numbers together, and they're 50, and then you will divide by 50. Alright, when you add all of these numbers up, you should get 1,145. Then you would divide that, because that's how you find your mean. You add up all the numbers, and then you divide by how many numbers you have, which is 50. When you do that, you will have 22.9. This is your population mean. Now we're going to do the same when it comes to a sample. So Autumn decides that she wants to take a sample of the population to determine how the sample mean compares to her population mean. In order to do so, Autumn has each teacher put his or her time in a bag without looking. She draws 10. The data of the teachers in her sample is below. So we're going to add these all together. When you add them together, you should get 202. No. Sorry, you should get 220. So then you have 10 numbers, 2, 4, 6, 8, 10. And we divide this by 10. And you will get 22. So now how does the population mean and the sample mean compare? Well, our population was 22.9 and our sample was 22. They are very close in number. So why is the sample mean not exactly the same as the population mean? This is because the sample is not going to always give the exact number, because you will have different people in the population and different responses each time you sample. So if you were to start over and redraw 10 data values, do you think her sample mean would be the same? If you were in class, we talked about this and we said no, it would not, because it is very rare that you are going to draw the same 10 values again. So all this is called sampling variability. The value of your sample statistic will vary depending on the sample you happen to select, because different samples may include different individuals from your population. This is called sampling variability. So this is where it is slightly different from what your population mean would be. All right, so find the median of the sample from the data below. So this is to find the sample median. These are your steps. You're going to order the data values from least to greatest. So we'll start with 5. And you have to include all of them, even if they repeat. Alright, these are all of our values. Now you're going to identify the middle value. And we're simply going to do it like this. 1, 1, 2, 2, 3, 3, 4, 4. And we can't do any more, because then I'll cancel out both of them, which means we have 2 values in the middle. If you have 2 values in the middle, you are going to add them together and divide by 2. If you add 20 and 20 together, that gives you 40. You divide that by 2, your median will be 20. All right, so to go on with sampling variability, we have 2 scenarios. The students in second period math want to learn more about the ages of Olympic athletes. They decide to use a sample size of 15 Olympic athletes to collect age data on. Scenario B, the students in 5th period math also want to learn about the ages of Olympic athletes. They decide to use the sample size of 100 Olympic athletes. In what scenario is the sampling variability greater? Once again, if you were in class, we talked about this. If not, we chose scenario A, only because to get closer to what the population would be, we need more samples. And it also goes back to being biased and unbiased sampling when you have too few samples. So, and then a visual we did to go along with that. So smaller sample size is equal to greater variability. That means it's going to be more different and vary further away from the actual population. The larger the sample size is less variability. And the image we use is if we just have a small sample, this is our small sample. This is the bigger picture we get. We can't really tell, it doesn't really tell us the whole picture. But the more samples we get, the more we can see the bigger picture. And this is closer to the actual representation of the population.